Hello everyone. Today we are going to perform an interesting activity on triangles and its properties. So the activity which we are going to do today is about the perpendicular bisectors of the sides of a triangle. So before we start the activity, I would just like to explain what a perpendicular bisector of a side is. So the perpendicular bisector of a side of a triangle is a line that bisects the side and is perpendicular to it. So here I would explain what does this mean. Let us say we have this triangle, naming it as A, B, C. So the line which will bisect BC means the line which will divide BC into two equal halves. Also that line should be straight. That means the line should be making a 90-degree angle with BC. So the line which will be making 90-degree angle with BC and which will be dividing BC into two equal halves would be the perpendicular bisector of side BC. Same ways, a line drawn on AB which is making 90-degree angle on AB and which divides AB into two equal halves will be called perpendicular bisector of side AB. So I hope you are all clear about the definition of perpendicular bisector of sides of a triangle. So let us now start with the activity. So to perform the activity, I have taken cutouts of three types of triangles. Here is the cut of my acute angle triangle. This I have a cutout of right angle triangle, and here I have cutout of obtuse angle triangle. So I will start performing the activity first with the acute angle triangle. I am going to name the vertices of this triangle. Let me name it as A, let me name it as B, and this one as C. So now here we are going to work on the perpendicular bisector of the sides. So one thing that I would like to make clear, what is the point of congruence of the perpendicular bisectors called? So I'm going to give you here its answer. The point of congruence of the perpendicular bisectors of the sides of the triangle is called circumcenter. So now what are we going to do? We will be finding perpendicular bisectors of the sides of the triangle in all our three triangles cut out. Let us start with the acute angle triangle. So I want to find perpendicular bisector of BC, for which I am going to use a simple paper folding technique, since I want to find the line which will make 90-degree angle with BC and which will divide BC into two equal halves. So I'll simply do a paper folding technique. I'll make sure that my B vertex and C vertex, they coincide with each other. I'll overlap them like this. I'll make a crease. This crease is the bisector, which means this crease is dividing my BC into two equal halves. So I'll take a pencil and a ruler to draw the perpendicular bisector and make sure that this line is a straight one. This is the perpendicular bisector of BC. Same ways, I will now fold the side AC and make sure that A vertex and C vertex overlap each other. I'll make a crease. This crease is the midpoint of AC, which means this crease is dividing AC into two equal halves. Again, I'll make sure this line is a straight one. I've got my second perpendicular bisector. Again, same paper folding technique. I'll overlap A and B. I'll make a crease. This crease is the midpoint of AB. You can now observe that all three perpendicular bisectors are meeting at a point. This is called the point of congruence. I am naming this point of congruence as O here, and this point of congruence, as told you earlier, is called circumcenter. So clearly you all can observe that the circumcenter in case of acute angle triangle, lies completely inside the triangle. This is our first observation. So I'll write my observation here. In acute triangle, circumcenter, where does it lie? It lies inside the triangle. We are talking here about the circumcenter. I'm considering now my second cutout, which was of right angle triangle. So here I have my next cutout of right angle triangle. Again, I will mark the vertices here. Let me name it as A, B, C. Let us now again find the perpendicular bisectors of all the sides. Same technique I am going to use here. I'll overlap B to C. This crease is my midpoint of BC. I'll take my pencil and my ruler and make a straight line like this. Now I'm going to find midpoint of AC and overlap A to C. This crease is my midpoint of AC. This way. Now I will overlap A to B, and this point is my midpoint of AB. I'll again take my ruler and my pencil and I'll join this line. So you will make an interesting observation over here. See, in this right angle triangle, this is the point of congruence of all the perpendicular bisector. This is the circumcenter. I'm marking it as O, and this is circumcenter. See, you will make an interesting observation over here. In case of right angle triangle, the circumcenter lies at the midpoint of the hypotenuse. You will see this. This is lying at the midpoint of the hypotenuse. So my second observation is, in right angled triangle, it is lying at the midpoint of hypotenuse. So let us now do the same for the obtuse angle triangle. Here is my obtuse angle triangle. Same thing I'm going to do. I'll mark the vertices A, B, C. So now by paper folding, I'll find the midpoint of AB. I'll make sure the A and B vertices, they overlap each other. This is my midpoint of AB. I've got it. I'll draw a line just like this in the crease, a straight line like this. Now I'll take midpoint of side BC and make sure that the points B and C overlap each other. So here my B and C are overlapping each other. This is my crease. Let me just fold it once more to get the accurate midpoint. So this is my midpoint. I've got my midpoint. And now draw it like this, a straight line. Now I will find out the midpoint of A and C. I'll make sure that my A, C vertices overlap each other. Yes, now they are overlapping. And now you will see this crease that I have got here is a midpoint. I'll draw, make sure I'm drawing a straight line. This is my third perpendicular bisector. So here you have observed that this circumcenter, in case of obtuse angle triangle, is lying completely outside the triangle. So here I am going to make my next observation. In obtuse triangle, circumcenter lies outside the triangle. So here we have seen how only by paper folding we were able to find out that in acute angle triangle the circumcenter lies in the interior of the triangle. In right angle triangle the circumcenter lies at the midpoint of the hypotenuse, and in the obtuse angle triangle the circumcenter lies outside the triangle. I hope this activity will help you to understand the concept. Thank you and have a nice day.